Hello, this is Domenico with Easynomics, and this is the third part of a paper 3 practice looking at a downward sloping demand curve. And in the previous two videos, we looked at illustrating revenue maximization where MR equals 0. So the MR curve will be downward sloping and will hit the midpoint across the demand curve from 0 to 160, so it was 80. And then we calculate total revenue at that point, price according to demand. Here we have the unit elastic portion of the demand curve when MR hits 0 and total revenue is at maximum. Price times quantity gave us total revenue. And in the second video, we covered looking at total costs of production, $12 million to provide these tickets for this Champions League final. And assuming that there are no variable costs, calculate the average fixed cost, which is the formula of total fixed cost divided by quantity. And here we had $12 million of fixed cost divided by the quantity at the revenue maximization level of output of 80,000 tickets. That gave us an average fixed cost on average per ticket of $150. So in this video, we're going to go over a little bit more theory. We're going to tackle this second part to this question. Here it says, assuming profit maximization. So let's make some notes here. Excuse me. Assuming profit maximization, calculate profit to be made from this particular match. But there's some additional information that we need here. Here it mentions that there are fixed costs of 12 million and that there are no variable costs. That's a key concept there that should be taken into consideration when we have these kind of conflicting objectives of the firm of revenue maximization, and then they throw it as profit maximization. You should know that revenue maximization, excuse me, sorry again, revenue, I'll call it revenue maximization, follows the rule of producing where the marginal revenue curve equals 0. And there are links in the video notes below to video tutorials that go into much greater detail as to why total revenue is maximized where MR hits 0. And we also know that the PED value is unit elastic, PED equals 1. Profit maximization is a different rule. Profit max occurs where the marginal revenue curve equals the marginal cost curve. And we need a marginal cost curve. We need a supply curve and see where it intersects with the MR curve. So that is the dilemma here. We don't have that supply curve illustrated, but there's some hints here to give us insight as to where can we achieve profit maximization, even though it appears that we have no supply curve to illustrate. So there's a few things that we need to go over, and this video is more focused on the theory. First, you should know that marginal cost is equal to the change in total costs over the change in quantity. Fine. But in another video tutorial, we can see that in graph A, we have total fixed costs that are constant, like rent being $100. Doesn't matter whether you produce 1 unit of output or 10,000 units of output within a month. The monthly rent is constant at $100 per month. But as you increase output, your variable costs increase. This could be the cost for labor, the cost for other capital resources that you employ to produce more units. So as the variable costs increase, the total costs increase. And essentially, the distance between the total cost and the total variable costs is the value of the total fixed costs. So from point A to point B is essentially going to be the same value of the x-axis to point A, or the value from point C to D would be also equal to the value of the x-axis up to this point. So what's being added is this variable cost. The distance from the fixed costs to here are your variable costs that continue to increase over time. And when we look at the average, when we take average fixed cost, total fixed cost divided by quantity, if you take a constant number divided by an increasing quantity, that average fixed cost curve is going to get lower and lower and lower and closer to zero. We'll have another video just to plot data and plot points so you can really see that. What we should pay attention to is the marginal cost curve. The marginal cost curve, again, is that change in total costs divided by the change in the quantity of output. And what's really driving this upward slope is not the fixed costs, because the fixed costs keep getting smaller and smaller and smaller. It is the rising average variable costs. And essentially, we can see here that the distance between the average total cost and the average fixed variable costs is the value of the average fixed cost at that quantity of output. So at this quantity of output, the distance from point A to B is the same from C to D. Thus, the entire distance from C to B are all of my rising variable costs. So with that knowledge, we can also say that marginal costs is the change in total costs or the change in quantity, but the total costs are not driven by, the changes in total costs is not driven by any change in fixed costs because they're constant. It's really driven by a change in the total variable costs divided by the change in the quantity of output. So please be mindful of that the marginal cost curve is the change in total costs, which is essentially the change in the variable costs. And here they're telling us that there are no variable costs. So there is no variable cost impacting my production. This is gone. So essentially, this is going to equal zero, no change in variable costs, over potentially a change in the quantity of output. Essentially, 0 divided by anything would give us a value of 0. So the marginal cost curve equals 0. Okay, so what does that mean in terms of profit maximization when MC equals 0? So that's what this video is going to be focused on. Profit maximization when MC equals 0. Let's make a note about that so we can really emphasize that point. So maximizing profit, and the symbol for profit in economics is pi. Maximizing profit when MC equals 0 under imperfect competition. And in imperfect competition, we have a downward sloping demand curve versus perfect competition, where you have a perfectly elastic demand curve. So profit max, where does that occur? How do we achieve profit max when MC equals 0? Well, there's a few things we need to be mindful of. If the marginal cost curve equals 0, then the profit maximum level of output will have the following characteristics. They're going to have the following characteristics. Yikes, I'm running out of space there. Following characteristics. Number one. One characteristic in terms of the output is that if MC equals 0, then the marginal revenue curve will equal 0. So that is the revenue maximization level of output. So if MC equals 0, the output level will occur also where MR equals 0. So with that being said, profit max occurs when MR equals MC But since MC equals 0, then profit maximization will also be where MR equals 0, because that's the point of intersection. Then MR equals 0. So profit maximization level of output is occurring right here. MR equals 0, and the supply curve is also equaling 0 at that point. Another characteristic, price will be positive, and price will not be $0. It's going to be priced according to the demand curve. So since the marginal revenue curve is going to be less than the average revenue curve, since we assume no price discrimination, which is discussed in another video, I'll have a link to that in the notes below, the price will be always greater than 0. So at 80,000 tickets, price according to the demand curve is $500. It is greater than 0. Some other points. I'm running out of space. I'll put third point. The output level. The output level will not be infinite. It will be finite, which we see again here, where MR equals 0, we have a finite level of output of 80,000 tickets. So it's a finite quantity. Number 4, price maximization, or profit maximization price will be at the midpoint of a straight downward sloping demand curve. Essentially occurring where PED is unit elastic. The price elasticity event equals 1. So again, here we see MR equals 0. That's midway across the demand curve, going from 0 to 160,000. Midway is 80,000. And we see that the PED value is unit elastic. PED equals 1. Again, highlighted in another video that will be linked in the video notes below. And finally, one last point, point number 5, the outcome of profit maximization, the outcome of profit maximization occurs where marginal revenue equals marginal cost. This will be the same as where revenue maximization occurs. And that occurs where MR equals 0. So all of this is basically telling us, all right, with this little hint here in the question, embedded in the question, there's a hint that since there are no variable costs, that's a signal that the marginal cost of production, the MC curve, is going to be equal to 0. Again, since it's the change in total costs, and that's essentially the change in variable costs, and there are no changes in variable costs, thus the MC curve is going to be 0. And thus, if that is the case, all of these conditions are going to be met, 1, 2, 3, 4, 5, and then we're going to see that proximate profit maximization of MR equals MC is going to be same as revenue maximization, where MR equals 0. So we have all the information we need to calculate profit. With that, let's also think about the supply curve. What's the supply curve going to look like? Well, we have a hint. we have tickets being sold in a stadium, and in the stadium, the maximum number of tickets that can be offered due to the capacity of the stadium is 80,000. Okay, so essentially your supply curve is going to be perfectly inelastic. It's going to be perfectly vertical. It's going to look like that. Supply equal my marginal cost. And I noticed that the PES, since it's perfectly inelastic, the price elasticity of supply is going to be equal to 0. And that's a result of this formula. PES is equal to the change in the quantity supplied over the change in the quantity. But the change in the quantity supplied is going to be no change. Price can go up and down. The quantity of output of 80,000, I can raise price to 1,000, I can lower price, but the quantity of seats in the stadium does not change. I'm not going to build more seats or destroy seats in the stadium. So essentially, there's no change in the quantity supply divided by change in quantity. I'm sorry. Oops. Change in price. Oh, man. Let me go back there. Change in quantity supply divided by the change in price. So I can change price, raise it up and down, but it's going to have no impact on the quantity of output or quantity of tickets. So 0 divided by change in price will always give me a value of 0. So PES equals 0. The supply curve itself is 0. So that is a signal that it is perfectly inelastic. And I'm going to highlight this point as well. There you go. All right. So the next video will ask you to answer this question. Assuming profit is maximization, calculate the profit to be made for the match. So look for the link to that next video, and then you can practice calculating that in that next question. If you have any questions, feel free to comment those questions below, and don't forget to subscribe and to like. Thank you so much.